What might we learn as simulators if we 3D printed our models? This is part A of a series, an introduction, and then what has changed in the last few years to make it easier to print our models, and some possible models that we might want to print. As with most folk in the simulation community, my eyes tended to be focused on my computer monitor. My architectural colleagues got to play with physical models, and I wanted to rejoin that club. Unlike many in the simulation community, I started out with physical models. They were part of my architectural training and practice, long before my work evolved into the development of tools to simulate the built environment. Yes, physical models take time to create, and occasionally blood was spilt during their creation. But whether via old-school sharp implements and cardstock, or with a 3D printer, I found physical models paid dividends for my own understanding of the design as well as my client's understanding. Classic uses for architectural models are, of course, to do shade and shadow studies. The next is understanding the relationships between spaces. Architectural models help with that. Understanding the masses of buildings and the interactions with the site. Mostly, models are a medium of exchange between the design team and client. And of course, designs evolve, and design teams are continually adapting their models or creating new ones to support what they're focused on at the moment. Home truths. Folk working with simulation tools are habituated to their quirks. Others in the design process and clients, no, not so much. Where we see abstract wireframe images in our models and we fill in all kinds of attributes, others simply don't see that. Look, I wrote much of the interface to a simulation tool, and I know its communication limitations, and when I hit a limit, I go elsewhere. My first alternative, Radiance. I first created alternative renderings of my models using Radiance. Goodness, it was a couple of decades ago. And after the simulation code we were working on was extended to export Radiance scene files, and we created a new E2R module. It allowed us to drive Radiance to get away from the unimaginable number of tweaks that you can make to the files. So here's a brief taste of what that process is like. The SP model is expanded to the native Radiance files, and the user selects the rendering attributes as well as setting up one or more viewpoints, and then hit the button and commission some visual computations. In this particular case, it's an internal view within a university administrative office. It gradually resolves in the preview mode to confirm, in a sense, the settings. Subsequently, I could then produce a much higher resolution rendering. If the simulation models were populated with furniture and fittings, i.e. everything is real, then it's easy to support detailed visual and thermal comfort studies. It forms a very good start for exploring sun patches in rooms, glare in workstations, and the like. However, where the goal was an interactive exploration with a client, Radiance is just too slow, and I would choose something like Blender. Once again, we added additional logic within the simulation tool to bring Blender into our workflow. What was that workflow like? Well, here's a brief session looking into a model and exposing portions of it for our client. And really, the thing that spurred my interest was passing by building sites and seeing utter chaos within facades. I pull up my camera, zoom in, and oh my goodness, who thought this up? Surely, if they had better imagination about how chaotic this facade would be, they would have detailed it differently. I've been in the 3D printing community since 2012, when it took a team of a half dozen folks to build a printer from hundreds of laser-cut parts. And at that time, I marveled at the pure dead brilliance of a printed house. Wow, it was way beyond our primitive printer. And I don't know what CAD resources they used to make the thing up, but it set me to dreaming. And that dream stayed in the background. But on the day the university closed its doors for COVID, I took delivery of a Prusa Mini 3D printer. And then the simulation tool facilities really began to evolve, and the workflow for creating solid renderings of simulation models began to come together. Okay, the Earth did not tilt on its axis, but what I found was not only that this was a powerful approach to model quality assurance, it broadened my ability to help others understand the implications of the changes my simulation studies were suggesting. Okay, some viewer homework. If Radiance is not in your current workflow, I've got several videos showing the cooperation between thermal simulation and Radiance. What was that workflow like? And if Blender is not in your simulation workflow, then have a look at a couple of videos. Yes, of course, those videos were made in the context of ESPR and Blender, but the features of Blender would be a useful supplement for just about any kind of simulation suite. The Blender video was in the context of a high-performance facade system retrofit to an existing terrace of houses. Blender played its usual roles. It also was used to plan the manufacturing process that generated the actual replacement facades for the houses. I also made a video about ESPR and Blender in the context of an urban office model. What you might notice from that video is that Blender is much more than a visualization tool. It's also an excellent portal for previewing what will be printed, correcting minor glitches, and then outputting the STL files which 3D printer slicing software relies on. Before we get into fine-tuning workflow for 3D printing simulation models, if you haven't seen it and don't know what that workflow might be like, here's a video I made in 2022 about that. What you would have noticed in that video is there are lots of choice points in the workflow related to the design of the simulation model, use of intermediate tools such as Blender, also choice points in the slicing software, which prepares the instructions for turning it into a physical model. And yes, there was friction in that workflow. Being pedantic was a really good habit. Paint dries faster than 3D prints, and self-inflicted glitches in the workflow can be as bad as hardware faults. So a bad 3D print is kind of like dropping a cardstock model on the way to a design meeting. And it's got an awful similar feel to doing a bunch of simulation runs only to find out that one of the attributes of the model was off and you've got to start all over again. And what you also might have gathered from that video is getting comfortable with printing workflows takes time. Since that video was made in May of 2022, the speed of 3D printers has essentially doubled. Here's an example. Looking at a model of a flat in a historical building that essentially covered the bed of the Prusa Mini, well, that took 15 hours and 55 minutes to print. Printing the same model at the same size on a newer Prusa Mark IV's takes 8 hours 41 minutes. Comparing the mini print volume with my Mark IV's, well, we can certainly get larger prints in there. And there are lots of printers on the market with even higher volumes. So yes, now we have the option of 3D printing that model bigger. If I scale up that historical house print to the extents of the Mark IV's, well, that takes the printing time from 8 hours 41 minutes to 17 hours and 30 minutes. That's a serious additional investment in time. So it really is a case of yes, you could, versus but should you? There have also been workflow improvements. A simulation tool logic and the data model for 3D entities certainly has evolved in the intervening years. And slicers have evolved in several very useful ways. There's certainly less risk when printing ceiling elements in models, and we can vary the vertical resolution of printing so that we can get higher resolution in areas like architraves and the like. And there's also now an ability to selectively add to and cut away from a model to expose, for example, interior details. And there are simply more examples that users can now learn from. What has not changed all that much are the classic 3D printing constraints. Scale. How do the simulation model dimensions work within the print volume? Gravity. It's still problematic if we have models that suggest that parts of the building need to float in midair. And there's the resolution of what we can print. Do we actually lose thin layers like chipboard or furniture legs at the scale we're trying to print? Time, as we can see, increases significantly as we adjust the size of our models. And also what hasn't changed much is the imperative to consider when we're designing our simulation models that they might be printed. Here are the emerging challenges and opportunities as I see it. Choosing what to print to communicate relevant information. Well, let's use that 4-room test model. If it's printed about 50 millimeters wide in a light color, someone with good eyes can see inside, and it's still possible to see the window frames. White is certainly okay for the eyes, but it's fairly rubbish for photographing. If we print it 85 millimeters wide in gray filament, well, it's easier to see the facade details, but seeing inside is, well, less easy. And if we do look inside, we see that the ceiling is a bit rough. If what is important to the viewer is the relationship between the rooms, then a print without the ceiling supports much easier understanding. The choice of size, color, and openness, well, those are done in the printer slicer or in the printer itself, and thus can be adapted to fit the needs of the viewer. If we want to use architectural models to show differences between two construction types, say a cavity brick wall versus thicker walls in a passive house scheme, then a slice of the building might offer clarity that a whole building print might not convey. We also have the option to use the infill within the print to highlight the sectional nature of the print. Another option, which addresses multiple issues, is whether we allow our models to be opened up. In the context of this historic building, the half-meter thick walls do begin to come across while looking at the outer faces of the print. However, being able to open up such a model makes for an even richer experience. The facade thickness is even clearer, and the relationships between the rooms now shows that the non-orthogonal nature of the layout of this apartment. It also allows particular details of the room, such as the insert for the radiator in the front facade, to be seen. If we turn to a model of a stone cottage, the external view gives only slight hints as to the considerable depth of the masonry. When printing, I used the slicer to split the model so that we could study the occupied space as well as the roof. So, when opening it up, we can see not only the splayed openings of the windows and the included furniture, the roof portion is able to also show the wood structure which supports the roof, and there is the opportunity to use different resolutions of the same design, where we create a variant focused on a specific issue. In this case, I took that now familiar model of the historic apartment, and in one section I added additional details to the floor and ceiling to represent the construction at the front facade. I did this in order to support discussions with the construction team who were planning on stiffening the floor structure. Again, such changes in resolution are often used by simulation teams to explore an issue on a small scale before applying it to the whole model. In other words, constrained introduction of complexity. In subsequent videos, I will be delving into these opportunities in greater detail. One will look at how one might use careful observations of render previews to catch errors in the original CAD or simulation models before entering into that long-running paint drying phase of a glitchy print. One will look at how to carefully look at different layers within the printer slicing software to identify gravity and resolution issues, as well as, hey, it's actually a pretty good means of communication with clients. And one will look at how we might tweak the original CAD or simulation model to deal with the gravity issues that we found. And another will look at how we might tweak the original CAD or simulation model to get around resolution issues that we might have noticed.